Let us discuss about the redox reactions. First of all, what do you mean by a redox reaction? Any reaction in which exchange of electrons take place between the reactants is called redox reaction. Next, say for example, A and B are reacting with each other to give the, let us say, C and D. In this reaction, let us say A has lost the electrons, so like this. A has lost the electrons, so A has been converted into A positively charged ion. So in this reaction, since A has lost the reaction electron, therefore this process is called as the oxidation. Therefore oxidation means any process in which loss of electrons takes place or any process in which de-electronation takes place is called oxidation. Next, if any other species gains the electrons, say for example B is gaining the electron. If B gains the electrons, it gets converted into B minus. Therefore any process in which gaining of electrons takes place or any process in which electronation takes place is called reduction. Next, usually which substances will lose their electrons or which substances will supply their electrons to the others. Say for example, if you observe the oxidation state of the central atoms in various molecules, say for example H2S. In H2S, the oxidation state of the sulfur is -2. Next, similarly in NH3, the oxidation state of the N is -3. Therefore, observe the oxidation state of the central atom in any molecule. If the oxidation state is least possible value, then that entire molecule will always act as the electron supplier, or that entire molecule will always loses its electrons, or that entire molecule will undergo oxidation. Therefore, the basic principle for a molecule to undergo oxidation is the central atom must have the oxidation state value as least as possible. You see here sulfur. For sulfur, least oxidation value is -2. In case of ammonia, the least oxidation state for nitrogen is -3. So therefore, in ammonia, oxidation state is -3. Therefore, ammonia will act as the electron supplier. Next, the electron supplier is also called as the reducing agent. Similarly, observe the water molecule. In water molecule, oxygen is in its least possible oxidation state. Therefore, water can also act as the electron supplier or water can also act as the reducing agent. Similarly, like that, first you select various types of the molecules. Say for example, another example I will give methane. In methane, the oxidation state of the carbon is -4. Therefore, in every molecule, wherever the central atom is in its least possible oxidation state, then that entire molecule will act as the electron supplier or reducing agent. Similarly, in general, which type of molecules will gain the electrons? See here in this reaction, B is gaining the electron, so it has got converted into B minus. Like that, you observe the various chemical species. Let us say KMnO4. Similarly, let us say N2O5. Similarly, let us say SO3. Like that, you observe the oxidation state of the central atom in various molecules. See here, what is the oxidation state of the manganese? +7. Manganese +7. So this manganese, this +7 is the highest possible value for the manganese. Similarly, nitrogen, what is the oxidation state here? +5. This +5 is the highest possible value for the nitrogen. Similarly, for sulfur, oxidation state is +6. For sulfur, the highest possible value is a +6. Therefore, here it is also exhibiting the +6. Similarly, XeO4, in the xenon tetraoxide, here oxidation state is +8. Therefore, when we have a set of molecules, first identify the oxidation state of the central atom in every molecule. If that oxidation state is highest possible value, then that entire molecule always act as the electron gainer or oxidizing agent. Here, if the oxidation state of the central atom is least possible value, it will act as the electron supplier or reducing agent. Whereas if any molecule in which central atom exhibits the highest possible oxidation state, then that molecule will gain the electrons or it will act as the oxidizing agent.